So I'm going to just a little bit on the interaction between glucagon and insulin. Nothing I don't think particularly complicated here, but we'll go through it. So we start with glucagon, which is the one people don't tend to think about. You know, we feel familiar with insulin, but glucagon is released, remember, from the alpha cells in the pancreas. It's released when the alpha cells, they also act as receptors. They detect a fall in glucose concentration. So if glucose decreases, glucagon's released, excuse me, and this will promote the conversion of glycogen into glucose. Shouldn't have used the same arrow, should I really? Glycogen is converted to glucose, and of course also our gluconeogenesis, making new glucose from simpler molecules, from things from fatty acids and so on, which will return the glucose, the levels of blood glucose to the normal levels. Now, what's going to happen here? And by the way, you'll see different versions for this. Sorry, I should have moved it across. You might see different versions of this. So you might come across the normal level of blood glucose being expressed like this: 90 milligrams per 100 centimeters cubed, and that's a fairly sort of standard, although it might fluctuate a bit around there. That's a fairly sort of standard way to put it. But you could also see the same thing written like that. Now it's actually the same value. This is grams per litre. Excuse me. These are the same thing, but you know, confusingly in the book, perhaps confusingly, they decide to use one in one place and one in the other. But it's the same value. It doesn't actually matter which one you remember to quote. Either one would do. Okay. But when the glucose level returns to around about 90 milligrams per 100 centimeters, or 0.9 per grams per litre, that is then received, or that the information, if you like, it's detected by receptor cells, beta cells, which also which secrete the insulin, and these alpha cells. It's detected, and these things are then will stop producing glucagon. So this is an example of negative feedback. It's the commonly quoted example of negative feedback. Negative feedback is when a system, they use this term system, we're talking about our bodies in this case. It's when a system receive or a mechanism, a process, does something to return itself to normal levels. It does the opposite of what's made it change. In this case, we didn't have enough glucose, so we've released more glucose into the blood. We've done the opposite of what the problem was. That's what negative feedback is. The feedback bit refers to the fact that it's constantly monitoring this, it's constantly sending information back. Blood glucose is too low, I'll release glucose. What's happening to it now? It's going up. What's happening to it now? It's going up. What's happening to it now? It's going up. What's happening to it now? Now it's reached the right level. Let's switch this off. So that's what negative feedback refers to. A process that returns it back to its normal level, if you like, or it stabilizes. There's a good way to put it. It stabilizes the system by reversing whatever is causing that thing to change. In the case of things like in the case of insulin, because it was the opposite effectively, where insulin, which would lower blood glucose level if it got too high, released from the beta cells, of course, detected release from beta cells. They show these graphs in the book. I'll just briefly talk about those. What it's trying to show you in here, let's use a different colour. They actually quote in the book on the y-axis. It simply says relative units. This is the case of what they're trying to do is say, look, it doesn't matter what we're measuring these in, we're just trying to show you what happens. And what happens is, if you have glucose, if you ingest glucose, you have it in a drink or in food or whatever it may be, you would expect to see a sudden spike in insulin production, and then the negative feedback kicks in and you stop producing it. Why? because blood glucose is returning to normal. So what we're seeing here is, that's switching off because blood glucose is coming back down again. In the case of someone who had type 1 diabetes, remember in type 1, someone wouldn't produce insulin or wouldn't produce enough of it, so you would expect that to stay quite down low, or not at all. Excuse me. Comparatively, it shows it below here. There is a graph which is showing what happens to the actual levels of glucose, and it shows you two. The top one being someone with type 1 diabetes. So what this is trying to show you is, and this scale is looking in terms of hours. So this is the kind of scale that it takes to return. The blood glucose level is already quite high. It's around about 0.15, I think, in the book, grams per litre. So this is quite high. It's above our level where we need to be, which would be 0.9 if this was looking at grams per litre. Someone who did not have diabetes, their blood glucose would peak briefly and then come back down. You're looking at maybe something about an hour. You can actually see on the graph it actually just slightly overshoots. And there's the correction happening from the negative feedback. We've released insulin. Now our blood sugar's gone too low. Let's stop releasing insulin. Maybe a bit of glucagon as well, and we're back to that leveled off value at 0.9. For the person with type 1 diabetes, the glucose level will still decrease. It just takes a lot longer. All the other process, respiration is happening still. So it will still come down, but it takes much longer, and it's already at that elevated level due to the fact that you can't, a diabetic person cannot remove the insulin from the blood using the normal methods of insulin that we discussed.